Do what? Do what? Yes. I have no idea. Okay. Thanks for letting me know. Hey, good morning, everybody. Sorry, running just a little bit late this morning. Okay, announcements. Today we're going to be looking at or addressing any questions that you may have over, I believe it's assignment 15. Is it 15 or 16? Graphing polynomial functions. Let's take a look at that real quick. Week 9. 15, yes. Polynomial functions and their graphs. And I will gladly address any questions that you have over the assignment. The first thing that I do want to mention is you should have seen an email that went out yesterday about the posting of your grades for exam 2. And I said that we would talk very briefly about this exam. I really don't have a whole lot to say because really the scores were, I mean, really good. That might be an understatement. I mean, phenomenal might be a better word. The highest score was a 106. The lowest score was an 83. The average was a 95. So in terms of, if I may, I just spend a little bit of time looking at this. Just want to maybe highlight what the number one missed problems would have been. Let's see. Looking at So problem number 20 um, would have been the most commonly missed problem. Let's take a look at problem number 20 just real quickly. Um, and yeah, I remember grading this, and it was problem number 20, A and B. So I'm gonna have to, because I don't have the test with me. Maybe I do. Do I have the test with me? Hold on, just a second. Yeah, there it is. Yeah, let's just look at this. Problem number 20. Um, the biggest issue with problem number 20 was the increasing and decreasing aspect of these problems. So I'm just going to zoom in here. On what intervals is the function increasing, and on what intervals is the function decreasing? Now, I said this, I know multiple times, and I stressed it in the notes and in the lectures, that this question of increasing and decreasing has nothing to do with the values along the y-axis. Has nothing to do with the values along the y-axis. In fact, if I could, I would erase those values along the y-axis. We're talking about if you're writing this graph along the x-axis, when is the function going up and when is the function going down? So as I ride the graph along the x-axis, way back over here at negative infinity, as I start approaching 0, my graph is going up. The graph is increasing as I read the graph from left to right. And the graph is increasing from negative infinity all the way up here to x equal to -1, where all of a sudden the graph is going to transition to now going down. So according to the x values, as I ride the graph from left to right, starting way back here at negative infinity, so the graph is way down here somewhere, but it's going up. And I continue going up all the way until I get to -1. Then at -1 I start decreasing, and from -1 to 2 I'm going.
You are in the meeting now. Recording in progress.
From -1 to 2 I'm going down, and then from +2 all the way to infinity my graph is going to continue going up. So parts A and B, I remember grading this. It wasn't just your class, it was my other college algebra class. This was a consistently missed problem. Again, I don't want to spend a whole lot of time here. The second most missed problem would have been problem number 8. And in problem number 8, first of all, our two intervals are from, looking at this inequality, that's everything that's less than 9. This is everything that's greater than 9. So if you just look at these two inequalities, your domain is -infinity to 9 unioned with 9 to infinity. We're not including 9 in our domain because neither one of these inequalities have the or equal to 9. Now, there's a question that we looked at in our homework that was kind of like this, and I said you also have to look at the equations. Now, in this first equation, the domain is infinity. There's no restrictions here. Now, in the second equation, if you set x squared minus 2 equal to 0, you'd be looking at the square root of both sides, and then you would get x is equal to plus or minus 2. Plus or minus the square root of 2, excuse me. Well, both of those are less than 9, so if you're told to plug in the square root of 2, you would plug it in up here, which you get an answer out. If you plugged it in down here, you wouldn't, because it would be undefined down here. But we don't have to worry about that, because the only things that we plug in into this second equation are things that are greater than 9. So any restrictions here don't get applied to the domain of G, because we wouldn't be plugging in the square root of 2 into this function. It would go up here. So I think one of the number one missed things about this was we thought that it was from negative infinity to positive infinity. We didn't recognize that there was a no or equal to part in this problem, or we just didn't do the problem. And I guess the third most missed question would have been problem number 15. So I'll just do a top 3 most missed questions. Problem number 15. So I'll talk about 15 and 16, because I think there were some common errors here with 15 and 16. And I think it had to do mostly with dealing with the fact that we had to add fractions together. I think that was the most troubling part for a lot of us. So parallel means same slope. So you have to find the slope of this line right here. So I'm just going to solve for y. So I came over here, I solved for y, and you get m1 is equal to negative 1/4. Since we're talking about parallel lines, we're talking about the same slope. So I set things up in my point slope equation, distribute the negative 1/4, and that gives us a negative 1/4 times negative 1 is a positive 1/4, and then you have to add 5 to that, because you got to get 5 out away this.
You are in the meeting now.
What the heck is
Recording
going
in
on?
progress.
I don't know what they're doing to keep restarting my meetings. Add 5 to both sides. Well, since we have a fraction over here, we have to rewrite 5 as a fraction with a denominator of 4, so that's 20/4. So your answer is y is equal to negative 1/4 x plus 21/4. And problem number 16, we're dealing with a perpendicular slope. So perpendicular means that we're dealing with a negative flip, so I wrote that right here. The nice thing about this one, we are given the slope of 3, so the perpendicular slope is going to be negative 1/3. And again, when you set this all up, you end up with a 7/3 that you have to add or subtract 2 from. So 2 is the same thing as 6/3, so 7/3 minus 6/3 is the 1/3. Alright, like I said, I didn't want to spend a whole lot of time going over this, because, I mean, there's other things to do in this class. I'll say this one more time, or say a couple things one more time. Number one, very pleased with the results, and it's really no surprise this test seems to be, compared to test 1, students tend to do a whole lot better on this test than on exam 1. It is a different type of test. You're not doing quite as much algebra work, but you do have to know a lot of definitions and a lot of concepts. Um, so again, good job. I advise that everybody spend some time looking at their graded exam that you can see on Gradescope. You can print that off along with all my annotations and comments, and compare that your work to the work on the key, which is available to you. So that's really all I have to say about that. We are in Unit 3 now. Yesterday we talked about finding the roots of polynomial functions, and today we're going to be basically finding the roots of polynomial functions, looking at how to find the y-intercept, which we already know how to do, talk about end behavior, and be able to sketch the graph of polynomial functions. Given that we just have a little bit of time, you know the drill. You need to have watched the lecture videos and begun looking at the homework, and we can spend our time talking about the homework problems that you have questions over, and I'll make reference to the notes and such in my lecture, but I'm not going to spend all class period going over things that I've already covered. So let's turn the table, so to speak, and let's answer your questions. How can I help you? How can I help you?
Number 8, please.
Number 8. Okay. Problem number 8. This is assignment 15, problem number 8. We had the function f of x is equal to a 2x to the fourth plus a 5x cubed minus a 28x squared minus an 87x minus 36. Woo! That looks like a doozy. Alright, let's see what we can do with this. Number one, I'm just looking at this already. I'm saying I don't know how to factor it. It's not even, it's a 1, 2, 3, 4, 5 term polynomial, so I don't know how to factor 5 term polynomials, so we're going to find, actually before we do that, before we talk about finding those zeros, let's talk about part A, the end behavior. If we're falling in line with what I did in the notes, the first thing I always do is find the end behavior. So that leading term, a sub n x to the n, is the 2x to the fourth. And so from looking at this leading term, we care about two things, n and a sub n. And when it comes to n, we care about whether or not it is even or if it's odd. And when it comes to A sub n, we care about whether or not it is positive or whether it is negative. So n, lose a little bit of highlighting, n is the exponent that we're talking about. So the exponent is 4, that is even. And then A sub n is the leading coefficient, so that's going to be our 2, and that is going to be positive. So we have that n is even, and it's positive. So a couple of tricks that I remember. Even, I see that B has this same in behavior. It's going up on both sides. So we're dealing with same in behavior, and it's positive. So all this is telling me that my polynomial function is going to rise on the left, and it's going to rise on the right. Alright, I don't know what it's doing in the middle, but I know that it's going up on the left and up on the right. So that's going to be helpful for us. Alright, so getting back to where I was talking, what I was talking about.
You are in the meeting now. Recording in progress.
What I was talking about was, the reason I was talking about factoring was because we want to find the zeros. We want to find the zeros. Another thing for idea for zeros are those x-intercepts. So I can't factor this polynomial. So to find those zeros, we're going to use synthetic division. So we begin with looking at the possible rational zeros. So we want to know where the factors of our constant, which is a 36, over the factors of our leading coefficient, which is going to be a 2. So the factors of 36, we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 18, and then finally plus or minus 36, all over the factors of 2, which are plus or minus 1 and plus or minus 2. Oh man, that's going to be a lot of possible rational zeros. If we just go ahead and list those out, and this is a good exercise, because what if I say, what are the possible rational zeros? Here we go. Possible rational zeros, plus or minus 1, plus or minus 2, plus or minus 3. So I'm just taking everything up top and dividing it by 1. Plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 18, plus or minus 36. And then we need to go through and divide everything by 2. So 1 divided by 2 is a half. 2 divided by 2 is 1, but I already got 1. 3 divided by 2 is 3 halves. 4 divided by 2 is 2, but I already got 2. 6 divided by 2 is 3, I already got 3. 9 divided by 2 is going to be 9 halves. 12 divided by 2 is 6, already got it. 18 divided by 2 is 9, already got it. And 36 divided by 2 is 18, already got it. Now we begin the testing phase. So, to the person that asked this question, did you begin the testing phase?
No, sir.
Alright. So, how many people are in your classroom? To the person that's asking this.
5.
5. So I would divide and conquer. Of the 5 of y'all, and all the other schools, y'all can do this also. Start testing, because I'm going to tell you right now it's going to take a little bit of work. Test x equal to 1. Someone test x equal to 1. Someone test x equal to negative 1. Someone test x equal to 2. Someone test x equal to negative 2. Someone test x equal to 3. And then, if you have enough people, you keep going. Divide and conquer. Divide and conquer on this problem. So I'll do 1, and while y'all are watching me do 1, or y'all do your own work, let's test 1. X equal to 1. So I'm going to write out the coefficients of my polynomial. 2, 5, negative 28, negative 87, negative 36. So we're going to go through and do synthetic division. So whoever's doing 1, you're in luck. I'm doing yours, but again, divide and conquer. Somebody do negative 1, somebody do 2, negative 2, 3, and so forth and so forth. Bring down the 2. 1 times 2 is 2. Add, you get 7. 1 times 7 is 7. Add, you get a negative 21. Times a negative 21 times what is a negative 21? I don't think I'm going to get there. That's going to be a 108. At this point, I don't even care. It's not 0. Now, the reason I told you to divide and conquer is because it's going to take some work to get there. Has anybody found the 0? Has anybody found the 0? Have y'all gone through and tested 1, negative 1, 2, negative 2, 3, negative 3, and so forth and so forth? Has anybody found a 0 of this function?
X equals 4.
X equals 4. All right, I agree. I mean, I'm looking at the answer key, but let's verify. X equals 4. So 2, 5, negative 28, negative 87, negative 36. Bring down the 2. That's going to be 8 and 13. Times 4 is going to be a 52. 52 minus 28 is going to be a 36. No, not 36, 34. Then times 4 is going to be a 136.
Negative 28 plus 52 is 24.
24. 24. I think that'll work out better for us. Times 4, that's going to be a 96. Then difference between these two is going to be a 9. 36, 0. Good. X equals 4. So, just going to come up over here. This gives us a 2x cubed plus a 13x plus 24 13x squared plus 24x plus 9 equals 0. Alright, did anybody else find a 0 of this function? Did anybody else find a 0 of the function? Anybody? Did anybody try -3?
No, sir.
Oh, no one, out of your group of 5, no one tried -3?
Not yet.
Try -3 on this guy. Two, 13, 24, 9. Bring down the 2. Times -3 is a -6. Add, you get 7. Times the -3 is a -21. Add, you get 3. Times the -3 is a -9. Add, you get 0. So, x equals -3 is also a 0 of the function. So we have now found 2 zeros of this function, 4 and -3. Now at this point, I'm going to move up where I have a little bit more room. We have a 2x squared plus a 7x plus 3 set equal to 0. This is a quadratic equation. Anytime that you get to a quadratic equation, I would just abandon the synthetic division process and I would solve by either factoring or the quadratic formula. And this just so happens to factor. The reason I know that it factors is I'm looking at the AC method. 2 times 3 is going to be 6. Are there factors of 6 that add up to 7? Yes, there are. What are those factors? 6 and 1. So, AC method, what are the factors of AC? AC is going to be equal to 6. That sum to B, B is equal to 7. So the factors are going to be 6 and 1. So let's start with the 2x squared. The only way to make 2x squared is a 2x and an x. So how am I going to make that 6? I'm going to take 2 and I'm going to multiply it by 3. And then to make the 1x, I'm going to take 1 and multiply it by x. And these are both going to be positive. So there's the factored form. So then I'm going to set each factor equal to 0. Which then means I get that x is equal to subtract 1 divided by 2, negative 1/2. And then subtract 3, x is equal to negative 3. And there are my other 2 zeros of this function. Alright, so what do we have so far? So far, we've collected our end behavior. And now we have our zeros of the function. And we have the zeros of the function. Now, In the notes, we talk about something very specific when it comes to zeros, and we talk about the multiplicities. So let's look at our zeros one more time. Our zeros are -3, -3, 4, and -1/2. So I'm going to write that out as the following. -3, -1/2, and 4. Then I'm going to talk about their multiplicities. -3 is repeated twice. And each of these are repeated once. That is even, and these two guys are odd. So what does that mean about the graph and the x-axis? Graph and the x-axis. This means that the graph is going to bounce at -3, and then it's going to cross at the -1/2 and the 4. Talking about multiplicities, that's talked about in the notes. One other bit of information and we can start graphing. The next thing I want to know is what is the y-intercept. So we'll call this part C. What is the y-intercept? And the y-intercept is always found by evaluating f at 0, which is always going to be equal to your constant. You plug in 0 into your function and it's going to equal your constant. So if I look at my original function way over here, when I plug in 0 for all of these x's, this becomes 0, 0, 0, 0. 0 plus or minus 0 is always 0. What are we left with? A -36. So my y-intercept is at a -36. Now we can use all of this information to start getting a sketch of this graph. Now, I'm reaching into my bag and I'm grabbing my calculator because we want to use our calculator. Let's begin by just roughly sketching what we have. Alright, so I'm going to go to a different sheet.
There's no volume.
Oh, this one doesn't have a different sheet. Let's just go over here. There we go. Actually, let's do this one. There we go, that has a graph. Okay, so let's start off by just drawing our coordinate plane. Alright, we have zeros at 3, a -1/2, and 4. So the way I'm going to draw this is I'm going to let every 2 grid marks equal 1. So this is -1, -2, -3, -4, 1, 2, 3, 4, 5, and we'll plot our points along the x-axis, -3, -1/2, and 4. I know that my end behavior rises on both the left and the right. And because my y-intercept is at -36, I'm going to scale my graph appropriately. Let's do it like as so. We'll do, this will be -10, negative 30, negative 50, and so forth and so forth. So every single point along my y-axis is a value of 10. And so negative 36 is going to be about right. So 30, 40, so negative 36 right about there. Now, at this point, I want some other values, additional points. Actually, before we do the additional points, let's go back real quickly and look at our multiplicities. At negative 3, the graph is going to bounce, and at negative 1/2 and 4, the graph is going to cross. So I can get a rough sketch of this graph. It's going to come down, it's going to bounce, it's going to come back up, it's going to go through that x-axis, it's going to cross through my y-axis, and at some point it's going to come back up. Now, honestly, that would be an acceptable graph. That would be an acceptable graph for me. But if I want to get a better graph, if I want to get a better looking graph, I'm going to plot some additional points. So what if I want to know f at negative 2? So in my calculator, I'm going to first of all get the expression lined up here. In my calculator, I'm going to first of all do negative 2, enter. And then I'm going to start plugging in this expression. So we have 2, then I'm going to do second answer to the 4th, plus 5 second answer to the 3rd, minus 28 second answer squared, minus 87 second answer, then minus 36, hit enter, and we get 18.
You are in the meeting now. Recording in progress.
F at negative 2 is equal to 18. So, again, if I'm keeping in line with the fact that every single one of these is a multiple of 10, that's really where the function should be at that point. So I'll just come down and I'll do like this now. I'll just redraw it, and I'll just erase. There we go. And, you know, because of time, we're running out of time here. Let's do f at 1. And the nice thing about plugging it into my calculator like this, all I have to do now is do 1, enter, and I'm going to scroll back up to my previous expression where I had the answer values, hit enter, and I get negative 144. Now, I can already tell you that that's going to be way down here somewhere. I mean, maybe it's way down there. So the graph is going to come all the way down there. If we want to do f at 3, all I have to do in my calculator is do 3, enter, scroll up. Wow, it's even going down further than that. F at 3 is equal to a negative 252. But if you do 4, look, we get 0. So that even goes further down, way down here. So the graph is really looking something like this. And that's the sketch of our graph. Again, if all you had done was that dotted line that I did initially, I would have accepted that answer, because why did I accept that answer? Number 1, you had the correct end behavior. Number 2, you had the correct intercepts. And number 3, you had the correct fact that the graph is going to bounce at 3, it's going to cross at negative 1/2, and it's going to cross at 4. And you have roughly sketched the correct y-intercept. And that's how you graph these functions. Now, what made this problem a doozy, so to speak, was the fact that we had to go through a synthetic division process, and the first real zero that you would find would be here at negative 3. Now, I have a 100% guarantee when it comes to exams or quizzes. On a problem like this, if I tell you to graph, and you have to go through the synthetic division process, I have a 100% guarantee that says the first zero that you will encounter will be somewhere between plus or minus 1, negative 1, plus or minus 2, or negative 2. Or, if it's not 2, then, if that's not a possible rational zero, then it'll be between the plus or minus 1 and plus or minus 3. I will always make it so that if you go systematically through your possible rational zeros, one of the first 4 possibilities, so plus 1, negative 1, plus 2, negative 2, those are 4 possibilities. One of those will be a zero of the function. 100% guarantee. I am not going to make you on an exam or a quiz, especially when it comes to graphing, go through synthetic division more than, here you'd have to do it 6 times. 1, 2, 3, 4, 5, 6 times before you ever got to the actual zero of the function. I'm not going to make you do that. So, the point that I want to say there is, as long as you go through the first 4 possibilities and your algebra is correct, you will find a zero of the function, and that's in regards to a quiz or exam. Alright, so to the person that asked this question, and then also to everybody else,
Your conference is scheduled to end in 2 minutes.
does this make sense how you would go about graphing this function? Yes or no? Thumbs up or thumbs down?
Yes, sir.
Make sense? Alright. As you just heard, our conference is about over. If you continue to have any questions over this, please email me or reserve those questions for Friday, which we will meet on Friday. And I have to emphasize again that you take the time to watch lecture videos and start working through the homework for Friday's class. Friday we're going to talk about rational functions. And we'll do whatever we can to answer any questions in class over that on Friday. We will also have a quiz on Friday. So, short amount of time that we have for talking about rational functions on Friday. Alright, so with that being said, I guess I'm going to say goodbye for today. And I'll see y'all on Friday. Take care.
Your conference is now over. Goodbye.